Alrighty. So here we have our text being drawn on the screen, and I'm relatively happy with the positioning of it. It maybe doesn't look that great, but I think it's okay for right now. So, what I definitely want to do is go ahead and shrink our player, our cursor right here, and I think that will result in much better spacing and just a better looking game if we go ahead and essentially shrink our grid units by half, right? So if we scroll up to the top here, I guess it's not actually at the top. Okay, I want to say see, so if our grid width is well, okay, we'll just start with this. So we should just be able to say 2, and then we will get something that is, well, our text now looks like it's spaced appropriately. The size of our cursor is off, though. Um, so let's go ahead and change that. What I think I have decided is that I really don't like using this pixel size for our character. Maybe we'll want to use it for other things, but I think it would be clearer to just directly say that, hey, our character is the size of one cell, right? So we can go ahead and draw that sprite map unscaled and get that working. So if we go ahead right here, let's say draw sprite map unscaled, and then yeah, we want this to be cell screen width and cell screen height. We can compile, and something looks off there, doesn't it? In addition to this weird little like overhang there, this is definitely not the same width as like this W, right? And this is probably, well, real quick, let me make sure that I did say screen width there. Okay, so this might be a bug in our draw unscaled, right? See, what are we doing? We get the sprite row, sprite pitch, the row, that all looks good. Right over sprite height, and then right here, yeah, we want that to be width, not height. Okay, now that's looking much nicer. Okay. And we can go ahead and see that we're still able to get flush up against the screen here. Because our dimensions are still in even intervals of the screen. What I would like to do now is go ahead and say that we have we're going to look for 16. We want to have 32, right? Since now our width is half of what it used to be, we want to go and say that we have that. Oh, wait. Wait a second. Yeah, that's we don't want that divide by 2 anymore. So we'll have 32 units and 9 lines. All right. So that's looking relatively good. One thing that we might want to think about moving forward is that right now the number of grid units we have is determining the size of our block. And that can lead to some kind of weird things where we're stuck making our game with 32 wide, right? And maybe we don't want that. Maybe we want to say that we have a little more variety and options available to us. So we might do something like we draw a border around the screen. So we keep our grid as whatever aspect ratio we want and whatever size. So that, if we have a smaller map, the text doesn't get bigger. It's the same size. We just draw it in a smaller screen inside of our window. Maybe that's a bad idea. I'm not exactly sure. I'm not crazy about it, I can tell you that. But we will see. So right now I'm moving around using the cursor keys, which is all well and good. But I would like to go ahead and click on something to go ahead and move the cursor there automatically, right? So what I want to do is start getting a new type of event. Now, in pretty soon, I think we're going to want to separate this code out. Right now, it's pretty weird, I think, that we are doing all of our gameplay logic inside of this main function. So really, what we would want to do probably is have something like this, where we say, all right, let's do a get input, and then the get input would do like this type of thing, and then we would have an update function, right? And rather than saying, hey, if the key code is this, then move the player's position, really what we would do is say something like, we'd have a variable like movement direction equals up, right? Or something like that. Or, I guess in this case, left. And then in our update, we would go ahead and look at all of our input instructions that we got. So we would kind of be converting these key presses that we're getting from the operating system into variables that represent the types of things that are happening in our game. And that way we can go ahead and separate out the gameplay code from the operating system code. For right now, I'm going to go ahead and just sort of punt on that and try to get a little more complicated input code going on, and then I think we will get a better idea of how to solve that problem. So this is something that I feel pretty strongly about with programming. A lot of times you will hear people tell you that you want to do things right the first way, and you want to go ahead and make it as robust and as close to your goal as possible. And that's all well and good if you know what your goal is. Like, honestly, if I were writing this code, and not doing it in like an instructional sort of way, I probably wouldn't start off with this. So I would start maybe closer to my final solution. But I don't think that there's any harm in going about programming and just, trying to do the simplest thing, see what works, and then you start to move closer in increments to your goal. And that way you don't wind up building this very complicated, intricate system that gets you to your goal, before you know what your goal actually is, right? So that is just a little bit of programming opinion from me. You can take it or leave it, but that's certainly how I go about things. So here, let's go ahead and say we're going to have an event type, and this is going to be a motion notify event, right? So this is things coming from the mouse. It's probably the same type of event that would be generated, like if you have an eye tracker or something controlling your mouse. This would probably also be a motion notify. So this is event.xmotion.x, and then we have .y, right? So let's go ahead right here and keep this. We'll call this mouse position, right? And we'll say that mouse position dot x equals 0 and mouse position dot y equals 0, right? And then here we can say mouse position dot x equals that, mouse position dot y equals that, right? And I'm going to go ahead and print f these values. Again, with the forgetting to do the new line. Oh, what did I call it? Mouse position undeclared, because I called it mouse position. That's a weird one. Never made that mistake before. All right, so let's see. It looks like we aren't printing anything. Oh, I bet I know why. Because right here we're doing this select input on, and we have all of these different masks, right? Oh, and we're like ORing them together, right? So I think what we want is pointer motion mask, right? I think that should be it. Yeah, okay. So now we are getting a pointer motion. You can see the numbers are printing down the bottom. So if I go up here, I should be approaching 0, 0, right? And yeah, pixel perfect, 0, 0 right there. And then go here, I should be getting to like 1600, 900, right? And we can see if we move this window around that this is still the correct sort of thing, right? So this is relative to the window. So we don't have to worry about where the mouse is on the screen. We only have to worry about where it is in the little window on the screen, which is really nice, because if it wasn't giving it to us in that way, we would want to go ahead and convert it anyway. So it's very good that we have that. Now what I want to go ahead and do is say if event.type equals button press, right? In fact, actually, we can go ahead and see what this is. Let's do a printf and say pressed, and we want to see what event or what key, right? Not key, but what number that is, right? So when I click, it looks like we print a 1, right? So we know that clicking with the left mouse is 1, And if I click with the right mouse, that's 3. With the middle mouse is 2. Okay, good to know. So let's say that if our event.xButton.button, well, actually, I remember in an email you had mentioned you wanted to look at switch statements. So let's go ahead and make it a switch statement. So the way a switch statement works is we are going to pass in a value, and in this case, it'll be button, right? And now that value is kind of implicitly referenced in the following code. So when I say case 1, like that, really what I'm saying is, hey, is event.xButton.button, is that 1? And if it is 1, then go ahead in here and we'll do something, right? And then I'm going to do a break, which is going to tell us, hey, I'm done with my switch statement. You can leave the switch statement. Then we can do case 2, and this will be something, and we'll do a break, right? And, actually, really, I don't even care about handling well, no, we'll handle the middle mouse button. It'll be bad form not to. We just don't need to do anything for either of those, right? And here, what I want to do is say, all right, we're going to say that player position equals mouse position, right? And remember that our player position is in pixels, not grids. So we can definitely get sort of offset from where we expect to be. But if I go ahead and start clicking, we see we are moving our player around. Now, I can do things like this, right, where I'm clicking and the player is not really where I want them to be. So next thing we're going to want to do is go ahead and convert that pixel into the grid, right? Well, luckily, we already have a function that does something like that, right? Where we go from grid position to pixel position. So now let's go ahead and make a function that's going to be pixel position to grid position. And this will take our pixel, and then we will write into grid X and grid Y, right? So the way this works is we will say that grid X equals, we go ahead and pull up Krita here, take a sip of my coffee. Oops, Krita got opened in another window. All right, so we have our space right here, and we have our grid, right? So what I want to say is, let's say that this is 50, right? So we have 0, 0, 50, 100, etc., right? Just for our X. Well, I want to say any pixel between 0 and 50 should be 0, right? That should be, because that's going to be the grid that we're on, right? If I have any pixel between 50 and 100, I want to say that it's going to be 1, right? So let's pull up our calculator and just try something where let's go ahead and say that we have 10 and our width is going to be 50, right? So if I take 10 divided by 50, I get 0.2, right? What if I get 49 by 50? I get 0.98, right? How about if I go 110 divided by 50? Well, now I get 2.2, right? If I have like 51 divided by 50, I get 1.02, right? So we see that we are getting these decimal numbers, right? Which is, it might seem like that's an issue because we want our grid position in whole numbers, right? Our pixels are whole numbers. We want our grid to be whole numbers. Luckily for us, though, the way division is handled in C between whole numbers is it can't convert a whole number to a decimal number, right? Or, I mean, it can, but if you're saying, hey, give me a whole number that is the result of two whole numbers divided, well, okay, it obviously can't do that without just converting it to a whole number. And the way that it's going to do that is it's just going to lop off the decimal part. So if you have 1.999999999 and you convert it to a whole number, it's just going to say, all right, that's 1, right? So that's actually ideal for our case, right? Where we're going to say this is going to be pixx divided by cell screen width. And then we can do the same thing for y, right? So now let's go ahead and say when we set our position, we are going to say int new player. Well, in fact, actually, yeah. This is going to be a little roundabout, but it'll just demonstrate that it's going to work, and then we can go ahead and do this nicely. So since our player position is specified in pixels, what we're going to want to do is take our mouse position, convert it to a grid position, which tells us the right grid unit, the cell that our player is going to be in. Then we're going to convert that into a pixel position to say where our player is. So a little roundabout, sure, but I think that's fine, at least for right now. Int grid y, and then we can say pixel position to grid position. Let's say mouse position dot x, mouse position dot y, grid x, grid y. Pass those in as pointers, right? Now we're going to say grid position to pixel position. And we're going to say grid x, grid y, player position dot x, player position dot y, right? So we're just going to write directly in to the values in the player position. Oh, that should not be capitalized. Boy, I accidentally typed that R and it's coming back to haunt me. So, this doesn't seem to be working. So, let's go ahead and print our grid X, grid Y. I'll go ahead and wrap them in parentheses like that, I guess. So, because, we're printing a lot of stuff. So I'll go ahead and do that so it's easy to see. All right. So if I click right here, that's 0, 0. It looks like everything I'm doing is getting to be 0, 0, isn't it? Just real quick, I'm going to check to see our... Okay, so we're going pixel position to grid position. I am passing in that mouse position, right? Yes, I am. Grid X and grid Y. So here, let's go ahead and say that this is going to be pix x, pix y. I'll go ahead and get rid of that other printf right here. You know, I guess we really don't need this one either. Okay, so we know that we are getting the correct values in there, right? You know, because we could imagine that maybe we were accidentally resetting the positions. So now let's go ahead and say that what is pix x divided by cell screen width? And you know, I also just want to see what cell screen width is, right? Okay, so it's 50 is our cell screen width. What's weird though is that we're saying that 512 divided by 50 is 0. Which obviously just isn't true. I'm wondering if there's some weird thing that I'm just not noticing. What if we just say int x equals 50 divided by, 512 divided by 50, right? And let's go ahead and print that at the end, right? Yeah, okay, so that is 10. So why is... why on earth is 512 here divided by 50? Why is it that? I'm going to do something weird. What if I wrap it in parentheses? I don't see why that would matter, but you know, it could be a weird compiler bug. Well, I'm going to go ahead and just Google that real quick and say integer division C macro. If I go ahead and convert this to an int, just to make sure. So what I'm doing there is saying, hey, if cell screen width for whatever reason isn't an integer, because remember it's a macro, right? So it's just going ahead and replacing all the instances of it with the characters 5-0 in this case. Oh, actually, I totally know what it is. Yeah, okay. This is silly of me, and I can go ahead and explain it to you so you don't have to make the same mistake. So remember, we defined our screen width to be screen width divided by grid width, right? So that means that everywhere in the game where we type cell screen width, we are going to perform this mathematical operation, right? So really what I want to do is that, right? So I want to wrap it in parentheses, because right now we're saying, when we say pix x divided by cell screen width, that's getting expanded into pix x divided by screen width divided by grid width, right? So that's going to be 512 divided by 1600 divided by 32, right? So that's going to be 0.5-ish, right, divided by 32. And remember, since we are dividing an integer, we're just going to get 0 divided by 32, which is going to be 0, right? So we'll go ahead and wrap these in parentheses and say, hey, I want you to always do this division first, right? And now I can go ahead and click, and we get our player in a nice grid unit, right? Which is pretty cool, I think. Okay, awesome. So I think that'll do it for this video. In the next video, we might want to start cleaning up this code a little bit, because I want to go ahead and start actually implementing the gameplay, where now that we can move the player around, I want to actually go ahead and start being able to type things into the world, right? So that is what we will do for the next video.